This lecture is on electric power. It says concentrated power is not rendered harmless by the good intention of those who create it. That's a famous economist named Milton Friedman. Power is the rate at which we use energy. And we talked about this earlier in the year, but now we're going to talk about it in terms of electrical power. So how do we relate it back to what we're talking about now? The goals for this unit are that you be able to calculate the electric power given the means, and that you be able to understand the origins of the various power equations that we have. There's actually 3 of them we're going to talk about. So, electric power is the rate at which energy or work is done. And you can actually calculate this using the formula P equals IV. And people say, well, wait a second, how do we do that? Because power is energy divided by time. Remember that current is a coulomb per second, and voltage is a joule per coulomb. So the coulomb cancels out, and what you get is joules per second, which is energy divided by time. So that's the origin of this P equals IV. Now remember, P is power, which is measured in watts. It is very, very common to see kilowatts, megawatts, and gigawatts. So you need to be able to convert between those. I is measured in amps. It's electrical current measured in amps. V is voltage, which is measured in volts. Now, in addition to this equation, there are 2 other alternative power equations that we're going to talk about, and those are these. P equals I squared R and P equals V squared over R. Now, the origins of both of these equations are by substituting in using Ohm's law. So, for example, the original equation is P equals IV, but the V is missing, and instead I have an I and an R. Well, remember, V equals IR. So all I did was substitute in for V another I and an R, and that's how I got I squared R. I did something very, very similar in this one, but instead of substituting in for V, I substituted in for I using Ohm's law. So you don't have to use these. You can use Ohm's law as an intermediary step if you want, but it is nice to be able to see the origin of those equations. Now, way back in November, remember we talked about how electricity can do physical work. So you can actually set P equals IV equal to energy divided by time. So you can actually see how fast energy is being used by a particular device like a light bulb based on how much current it draws and what the voltage is.